Picture this. You're walking through downtown Madrid, and you pass someone on the street. Short, stocky build, pale skin, maybe red hair. They're checking their phone, grabbing coffee, heading to work. Nothing unusual about that, right? But now imagine that person isn't quite human, not in the way we understand it today. Their brain is actually larger than yours. Their eyes are adapted for low-light conditions that no longer exist. And their ancestors survived in Europe for 400,000 years before your ancestors even left Africa. This isn't science fiction. For roughly 5,000 years, this was reality. Two different human species shared the same planet, hunted the same animals, and even fell in love and had children together. One of them was us, Homo sapiens. The other was our closest cousins, the Neanderthals. Today, only we remain. But what if that hadn't happened? What if both branches of humanity had survived into the modern world? Let's start with what we actually know, because the truth about Neanderthals is far stranger than any fiction we could invent. The split happened deep in our shared past. Somewhere between 500,000 and 700,000 years ago, a population of early humans began evolving in different directions. One branch would eventually become us, the other would become Neanderthals. By 430,000 years ago, we can see clear evidence of this divergence in the bones found at Cima de los Huesos in Spain, the earliest known Neanderthal lineage individuals. But here's what makes this story remarkable. For the vast majority of their existence, Neanderthals were the successful ones. While our ancestors were still confined to Africa, Neanderthals spread across an enormous range, from the Atlantic coast of Portugal to the mountains of Siberia, from the Mediterranean beaches of Spain to the frozen steppes of what is now Russia. They weren't just surviving in these places, they were thriving. And they weren't alone for long. Around 60,000 years ago, something changed. Homo sapiens began migrating out of Africa in waves, spreading across the Middle East and into Europe and Asia. For the first time in hundreds of thousands of years, two intelligent human species found themselves sharing the same world. What happened next challenges everything we think we know about human nature and survival. The archaeological record shows something unprecedented. These two species didn't just coexist, they interacted. At sites across Europe and the Middle East, we find evidence of both Neanderthal and Homo sapiens occupation, sometimes in layers separated by just a few hundred years. They were using the same caves, hunting the same animals, even using similar tools. The most remarkable evidence comes from our own DNA. In 2010, scientists completed the first Neanderthal genome and made a stunning discovery. If you're of European, Asian, or Native American descent, roughly 1 to 2% of your DNA comes from Neanderthals. That might not sound like much, but it represents something extraordinary. Successful interbreeding between two species that had been evolving separately for hundreds of thousands of years. The math tells us this mixing happened primarily during a 7,000-year window around 47,000 years ago. That's longer than all of recorded human history. For 7,000 years, these two species were meeting, mating, and raising hybrid children together. Yet somehow, only one of us made it to the modern world. To understand why, we need to understand just how different these two species had become. When you picture a Neanderthal, forget everything you've seen in cartoons or old museum displays. The slouching, knuckle-dragging caveman is pure fiction. Neanderthals walked upright just like us, but in almost every other way, they were built for a world we can barely imagine. Start with their bodies. The average Neanderthal male stood about 5.4 and weighed around 170 pounds, shorter than modern humans, but incredibly robust. Their bones were thicker, their muscles were massive, and their entire frame was built for power and endurance. These weren't evolutionary accidents. Every aspect of their anatomy was fine-tuned for survival in Ice Age Europe. Take their faces. Neanderthals had large prominent noses, not for show, but function. Those big nasal cavities warmed and humidified the frigid air before it reached their lungs. Their stocky builds minimized surface area, reducing heat loss. Even their limb proportions followed the same pattern. Shorter arms and legs conserved energy in cold climates. But perhaps their most remarkable adaptation was their vision. Neanderthal eye sockets were significantly larger than ours, housing eyes adapted for the dim, gray world of Ice Age Europe. During the glacial periods, much of their territory would have been shrouded in dust, ash, and limited sunlight. While this gave them superior low-light vision, it came with a trade-off. Larger eyes meant less brain space for other functions, a detail that would prove crucial later. Speaking of brains, here's where things get really interesting. Neanderthal brains were not smaller than ours. In fact, they averaged about 1,410 cubic centimeters, compared to our 1,350. By raw size, they had bigger brains than we do. But size isn't everything. The shape was different, elongated like a football, while ours are more rounded. Recent studies suggest this difference might have been significant. Our rounder skulls house larger cerebellums, the brain region associated with cognitive flexibility, working memory, and complex planning. Neanderthals, meanwhile, devoted more brain space to visual processing and motor control. Think of it as two different approaches to intelligence. Neanderthals were specialists, masters of their environment, with brains optimized for the specific challenges of Ice Age survival. We were generalists, adaptable, flexible, capable of thriving in diverse conditions, but perhaps not as perfectly suited to any single environment. These differences showed up in their technology too. Neanderthals created what archaeologists call Mysterian tools, based on the sophisticated Levallois technique. This involved carefully preparing a stone core so that a single, precise strike would produce a flake of exactly the desired shape and size. It was incredibly efficient, what researchers call a tool for every task. They knew exactly what they needed and how to make it. Here's what's fascinating. While Neanderthal tools were often superior in quality and efficiency, they showed remarkably little change over hundreds of thousands of years. The Mysterian toolkit that appeared 300,000 years ago was essentially the same one still being used 40,000 years ago. It worked, so why change it? Homo sapiens, meanwhile, showed something different. Our upper Paleolithic tools were more varied, more experimental. We constantly invented new forms, combined techniques, and adapted our toolkit to different environments and challenges. Sometimes our innovations were improvements, sometimes they were failures. But we kept trying new things. The same pattern appeared in their use of symbolic objects. Both species used red ochre pigments. Both created ornaments from shells and animal teeth. Both buried their dead with care. But Neanderthal symbolic behavior was often more conservative, more consistent across time and space. Ours was wildly experimental. It's tempting to see this as evidence of our superior creativity. But what if it was really evidence of our desperation? Neanderthals had lived in Europe for 400,000 years. They knew what worked. We were the newcomers, the refugees from Africa, trying everything we could think of to survive in environments our species had never seen before. Genetic studies have revealed something remarkable about that critical period around 47,000 years ago. The interbreeding between Neanderthals and Homo sapiens wasn't random or accidental. It was substantial, sustained, and geographically widespread. We know this because scientists can trace the specific chunks of Neanderthal DNA in modern genomes. Instead of being randomly scattered, these genetic segments cluster in particular regions and follow predictable patterns that tell a story. The analysis suggests a major pulse of gene flow that lasted roughly 7,000 years, about 300 generations. That's not a few chance encounters. That's a sustained period of contact, cooperation, and integration between two species. Some of the most compelling evidence comes from Denisova Cave in Siberia. There, researchers found the remains of Deni, a teenage girl who lived about 90,000 years ago. When they analyzed her DNA, they discovered something unprecedented. She was a first-generation hybrid. Her mother was a Neanderthal. Her father was a Denisovan, another extinct human species. This wasn't just Neanderthals and Homo sapiens mixing. All the human species were interacting, trading genes, creating a complex web of relationships across Eurasia. But here's what makes the Neanderthal gene flow so remarkable. Much of it has been actively preserved in modern human populations. Natural selection has kept many Neanderthal variants not despite their foreign origin, but because of their benefits. Take skin pigmentation. Some of the most common Neanderthal genetic variants in modern Europeans affect skin color, hair texture, and the body's response to sunlight. These weren't just random passengers in our genome, they were adaptive advantages that helped Homo sapiens survive in high-latitude environments our species had never encountered before. Other Neanderthal genes affect immune function. When Homo sapiens left Africa, we encountered pathogens our immune systems had never seen. Neanderthals, meanwhile, had been dealing with these Eurasian diseases for hundreds of thousands of years. By mixing with them, we essentially downloaded their immunological expertise. The implications are staggering. It means that Homo sapiens didn't conquer Eurasia through our own innovations alone. We succeeded partly by absorbing the hard-won adaptations of the species that were already there. But this genetic exchange wasn't entirely one way. Recent studies have found evidence of Homo sapiens DNA in late Neanderthal populations as well. The mixing was mutual, at least initially. So why didn't this process continue? Why didn't we simply merge into a single hybrid species? The answer might lie in the details of where and when these genes survived. Neanderthal DNA is virtually absent from the X chromosome and is reduced around genes involved in brain development and sperm production. This suggests that while Neanderthal Homo sapiens hybrids were viable and often advantageous, there were subtle fertility costs that accumulated over generations. In small populations, these costs might have been manageable, but as Homo sapiens numbers grew and Neanderthal populations shrank, the balance shifted. The genetic exchange that had once benefited both species began to work primarily in one direction. The end of the Neanderthals wasn't a dramatic conquest or a sudden catastrophe. It was something far more subtle and, in many ways, more tragic. A gradual fade that took place over thousands of years. By 42,000 years ago, Neanderthal populations across most of Europe had vanished from the archaeological record. The latest confirmed Neanderthal sites date to around 40,000 to 37,000 years ago, clustered in refuges across southern Europe, the mountains of Spain, the caves of Croatia, the coastal regions of Gibraltar. Recent genetic analysis reveals just how precarious their situation had become. Late Neanderthal populations show signs of severe inbreeding and extremely low genetic diversity. Some groups appear to have consisted of fewer than 1,000 individuals spread across thousands of square kilometers. These weren't thriving communities. They were remnant populations hanging on in increasingly marginal territories. Climate played a role, but not in the way you might expect. Neanderthals had survived through at least 10 major glacial cycles over their 400,000-year history. They were masters of Ice Age survival, but the period around 40,000 years ago saw particularly rapid and severe climate oscillations, what scientists call Heinrich events. Temperatures could drop by 10 degrees Celsius within decades, turning forests into tundra and back again. For Neanderthals, adapted to stable territorial knowledge accumulated over generations, these rapid changes were devastating. Their deep environmental expertise, knowing exactly where to find water during droughts, which caves provided the best winter shelter, how to predict animal migration patterns, became obsolete as landscapes transformed. Homo sapiens, meanwhile, approached these challenges differently. Instead of relying on inherited territorial knowledge, we developed more flexible strategies. Broader social networks allowed us to share information across larger distances. More experimental technology gave us tools for different situations. Our generalist approach, while less efficient in any single environment, proved more resilient when environments changed rapidly. The most significant factor might have been simple mathematics. Modern genetic studies suggest that the total Neanderthal population across all of Eurasia was likely never more than 70,000 individuals at any given time. That's smaller than a modern city, spread across an entire continent. Homo sapiens, by contrast, were arriving in waves. Archaeological evidence suggests our population was growing rapidly, supported by more efficient hunting techniques, better social organization, and the ability to exploit a wider range of food sources. Where Neanderthals specialized in hunting large game, we could switch between hunting, fishing, and intensive plant gathering, depending on what was available. The result was what researchers call a survival trap. Neanderthals found themselves in an impossible position. Their small populations made them vulnerable to random disasters, a harsh winter, a volcanic eruption, a disease outbreak. But those same small numbers also limited their ability to innovate, adapt, or recover from setbacks. As Homo sapiens populations expanded, they didn't need to actively displace Neanderthals. They simply needed to be slightly better at finding food, slightly more resilient to climate swings, slightly more successful at raising children to adulthood. Over generations, those small advantages compounded. The genetic evidence suggests this process took millennia, not centuries. It wasn't genocide. It was replacement through competition for the same resources by a species that was just slightly better adapted to changing conditions. In their final refuges, some Neanderthal groups may have persisted until 28,000 years ago, though these late dates are hotly debated. If true, it means the last Neanderthals lived alongside the same Homo sapiens who were painting the caves of Lascaux and carving the Venus figurines of Europe. They were watching our species develop art, music, and complex symbolic culture, while their own world grew smaller and quieter with each passing generation. So what if that slow fade had never happened? What if Neanderthals had found a way to survive their demographic bottleneck, adapt to rapid climate change, or find a stable niche alongside expanding Homo sapiens populations? The scientific evidence gives us some remarkable clues about what a world with two human species might have looked like. First, let's consider their cognitive capabilities. Neanderthals had the FOXP2 gene variant associated with speech and language in modern humans. Their hyoid bones, which anchor the muscles of speech, were virtually identical to ours. Combined with their large brain size, this strongly suggests they had complex spoken language. They wouldn't have been grunting cavemen. They would have been talking, arguing, telling stories, and passing down cultural knowledge just like us. But their languages might have sounded very different. With their different brain organization, more focused on visual processing and motor control, Neanderthal languages might have been more gestural, more concrete, less abstract than ours. Where we developed complex metaphors and symbolic reasoning, they might have excelled at precise, detailed descriptions of physical processes and environmental conditions. Their technology suggests they would have remained skilled specialists rather than becoming generalist innovators. Modern Neanderthal tools might have been incredibly sophisticated within narrow domains. Imagine medical instruments crafted with the precision they once brought to stone knapping, or architectural techniques that incorporated their deep understanding of material properties. Their social organization was already different from ours. Archaeological evidence suggests Neanderthals lived in smaller, more stable groups with less mobility than early Homo sapiens. In a modern context, this might have translated into more localized, community-focused societies. Where we built cities and nations, they might have preferred extended family networks and bioregional communities. The physical differences would have been impossible to ignore. Modern Neanderthals would likely still be shorter and more robust than Homo sapiens, with larger eyes adapted for low-light conditions. In a world with electric lighting, this might have given them advantages in certain professions: mining, deep-sea work, astronomy, nighttime emergency services. Their cold adaptations would have made them natural populations for polar regions, high altitudes, or other extreme environments. Where we needed technology to survive in harsh conditions, they might have thrived with minimal equipment. But perhaps the most profound difference would have been cognitive diversity. Just as we now recognize that neurological differences within our own species can bring distinct advantages, having two different human cognitive styles might have accelerated innovation in unexpected ways. Neanderthal visual spatial intelligence, combined with their precise motor control, might have led to breakthroughs in engineering, craftsmanship, or scientific instrumentation. Their more conservative, stability-focused thinking might have provided valuable checks on Homo sapiens' tendency toward rapid, sometimes destructive change. Or maybe not. The same factors that led to their extinction, small population sizes, reduced flexibility, difficulty adapting to rapid change, might have made them permanently disadvantaged in a modern world characterized by constant technological and social transformation. We also can't ignore the potential for conflict. Two intelligent species competing for resources have historically not coexisted peacefully. Even within our own species, small physical and cultural differences have been used to justify terrible violence. The differences between Homo sapiens and Neanderthals would have been far more profound, but we do know one thing for certain: they wouldn't have remained separate forever. The genetic evidence shows that whenever these two species encountered each other, they interbred. In a modern world with global travel and communication, the genetic barriers between them would likely have completely broken down within a few generations. The result might not have been two distinct species coexisting, but rather a more genetically diverse humanity, incorporating the best adaptations of both lineages. When we look up at the night sky, we're looking at the same stars the last Neanderthals saw 40,000 years ago. They were intelligent, creative, adaptive beings who survived longer than our species has even existed. They made art, buried their dead with flowers, cared for disabled members of their communities, and passed down complex cultural knowledge through generations. The traces of Neanderthal DNA in our genomes remind us that they didn't completely disappear. Part of them lives on in billions of people today, influencing everything from our immune responses to our skin color. In a very real sense, we are the hybrids. We are what happened when two human species met and chose love over conflict, at least some of the time. The Neanderthals are gone, but their story isn't over. It lives on in our DNA, in our capacity for both cooperation and competition, and in the endless human question of what might have been. In the end, maybe that's the most important thing they teach us, that survival isn't just about being the fittest. Sometimes it's about being the luckiest, and sometimes, if we're very fortunate, it's about being kind.